Hi, this is Andrea Hendricks, and I want to talk to you about how to write equations of lines. This section will differ from the previous sections in that in the previous sections we were given an equation, and from that we had to find some information, maybe the slope, maybe the graph, maybe points that lie on the graph. But in this section we're going to be given some information and we have to come up with the equation. So in this section our goal is to answer in the form of y equals mx plus b, or ax plus by equals c. These two forms are interchangeable, though the first is a little bit better because it gives you more information. Let's just kind of review those equations that we've talked about. Remember that y equals mx plus b is called the slope-intercept form of a line. The coefficient of x, m, is our slope. B is a y-coordinate of the y-intercept. In other words, the point 0b is the y-intercept. The ax plus by equals c is called the standard form of a line. And remember our special cases. X equals a number is a vertical line, and y equals a number is a horizontal line. Thinking back to the previous sections, what information do we need to graph a line? One of the things early on that we talked about is finding points. And remember how we need at least 2 points to get the graph of a line. Also, we could know a slope and a point. Do you remember how we talked about the slope tells you the rise and run as you move from one point on a line to another? So if you know a starting point, you can use the slope to get to another point. The last case is a far stretch maybe for you, but what if we know a point and a line that's parallel or perpendicular? In this case, the parallel and perpendicular lines tells us the slope of our line. Right, parallel lines have the same slope, so this is essentially the same as knowing a point and a slope. Perpendicular lines have slopes that are negative reciprocals, and we'll use that later on. So parallel have same slopes and perpendicular negative reciprocals. So the common thread between those three cases to graph a line is that we have to know a point and a slope. And that is the same information that we need to be able to write the equation of a line. Now the point and the slope may be given in ways that are not explicit. You have to do some work to find it. Now the point will always be given, so you're not going to have to do any work to find a point, but the slope is what you may have to work to do. So you're going to have several different cases. You may be given in your problem the slope directly and maybe a y-intercept point, or maybe you're given a slope and any other point on the line, or maybe you know 2 points on the line, or maybe you're given a point and a line that's parallel or perpendicular. So for those cases, the main thing that you need to be able to glean from those problems is 1 point and the slope. So in case 3 and 4, you're going to have to do some work to find the slope. Right? If you know 2 points, you can use the slope formula. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you know a line parallel or perpendicular, you will have to write that equation in the form y equals mx plus b, and then look at the relationship between those slopes to get the slope that you need for your problem. So let's start with an example of a problem where we want to write the equation of the line that has slope 3 and it goes through the point 0, 4. Well, remember how if we're trying to answer in the form y is equal to mx plus b, if we know the values of m and b, we don't have to do any work because all that work is already given to us. And the slope 3 is certainly given to us, so we know it's going to look like y is equal to 3x plus something. But this 0, 4 is a special point, right? That is the y-intercept point. So if you're given a point 0 some number, you already have the value of b staring at you in your face. So the value of b from this problem is that y-coordinate, which is 4. Now that does not work for any other point given. If you were given 1, 4, that would not tell you what the y-intercept is, only if it's of the form 0 some number. So this is the equation of the line that has slope 3 and goes through the point 0, 4. Now that is in slope-intercept form. If you had to write it in that standard form, you could just write it with the x and y on one side and the constant on the other. So you could subtract 3x from both sides to get negative 3x plus y equals 4. But generally in that form we don't like a negative leading. So if we multiply through by negative 1, it just changes all the signs. But any of those are equivalent. So just be careful in my math lab with how it tells you to enter the answer. If it says slope-intercept form, enter y equals 3x plus 4. If it says standard form, enter 3x minus y is equal to negative 4. Let's look at another example. What if we are told the slope is 1/3 and it goes through the point 0, negative 2? Well, we're told our slope, right? Well, 0, negative 2 tells us our value of b because that is the y-intercept point. So our equation, we don't have to do any work to obtain. We have y is equal to 1/3 x plus b, but since that's negative, we can write minus 2. Okay? Now, what if we were given 2.04 and 2, negative 6? Well, in this case, notice that 0,4 is our y-intercept. That tells us b is equal to 4, but we don't know the value of m. So to find the value of m, we're going to have to plug into our slope formula. Remember here we can label as x sub 1, y sub 1, x sub 2, y sub 2. So our m would be negative 6 minus 4 over 2 minus 0. So that is negative 10 over 2 or negative 5. So now that we know m and b, our equation is y is equal to m, which is negative 5x, plus b, which is 4. Now how can you check? You should be able to plug in 0, 4 and get a true statement. Plug in 2, negative 6 and get a true statement. So if I wanted to check my work, I'm asking myself, is 4 equal to negative 5 times 0, plus 4? And yes, that is true, right? I'm also asking myself, is negative 6 equal to negative 5 times 2 plus 4? So negative 5 times 2 is negative 10 plus 4, which is negative 6, so that's true as well. So I know that this is the equation that goes through those points. Now, what if we don't know either the slope or the y-intercept and we're just given 2 points, 1, 4, and 8, negative 3? See, neither one of those is a y-intercept because it's not 0 some number, and we don't know the slope. So we have to find that information from the problems. So the first thing that we would need to find is the value of m. And so here we're going to do y2 minus y1, so negative 3 minus 4, over x2 minus x1, which is 8 minus 1. So negative 7 over 7, or negative 1. So now that we know that, we need to find b. Well, to find b, we can use our y equals mx plus b. Because we know 2 points, so those can be our values of x and y, and we know the slope. So here you're going to plug in for x, y, and m, and then solve for b. So we can get 4, it doesn't matter which point you use, I'm using one without negatives, but 4 is equal to negative 1 times x, which is 1, plus b. So that's 4 is equal to negative 1 plus b. So to solve for b, we have to add 1 to both sides to get 5 is equal to b. So our equation here is going to be y is equal to negative 1x, or just negative x, plus 5. Now to check, we can see that those points lie on this line. If I plug in 1, the opposite of 1 is negative 1 plus 5 is 4. So 1, 4 satisfies the equation. If I plug in 8, my output should be negative 3. If I do negative 8 plus 5, I get negative 3. So both of those lie on that equation. So I know I have the right answer. So the process that you're going to use is to find the slope, then use y equals mx plus b to find the value of b. So what I mean by that is you're going to plug in one of the points given x, y, and the value of m so that you can solve for b. And you're going to answer in the form y is equal to some number times x plus b. And then if you need to convert that to the standard form, you can. Now, your book also uses a different formula called the point slope. They use y minus y sub 1 is equal to m times x minus x sub 1. You can use that. I'm just trying to steer you away from having to memorize another formula, but basically you're plugging in a given point and you're plugging in the slope. So the first step is the same. You have to know the slope and you have to know a point, but then where you're plugging in to get the equation is a little bit different. So let's look at an example where we want to write the equation of the line through